Alrighty then, and welcome to the Daily Space Weather. Forecasting space weather has become like a bodily function for me, so let's get through my bodily functions. We'll cover that and lots more today at the Smash News Network, least busted name in news. That's the past 24 hours from the Solar Dynamics Observatory. You're looking at ionized iron and helium there. 171 plus 304 angstroms. And we're going to show you some spectacular close-ups, as we're known to do the past 6 years. There's the Northern Hemisphere. That huge sunspot group in the lower right is indeed Beta Gamma Delta class, at least last I checked, an hour or so ago. Here's the equatorial view. And like we said yesterday, there are 5 new sunspot groups in the eastern limb. Also a huge filament down there. You can see that starting to get a little bit unstable looking. There is the view of that filament down in your lower left. And we may have to name that one after a living person today. Here are some extreme details. Fantastic view of that huge sunspot group. Here's one of the several rising groups in the northeast. And my favorite place for solar flares, besides that huge sunspot group in the northwest, is this group down here in the southeast. Again, that filament looking increasingly unstable here. We've got a very high likelihood of large solar flares. And we're going to talk sunspots, coronal holes, solar wind, magnetic fields, and lots more. So let's take a look at the SDO intensitygram, or SDO continuum for the yesterday plus today's data. And you can see quite a bit of growth there, especially in the southeast. A little bit of growth in the northwest as well. So again, most likely places to see a large flare are the northwest and the southeast. Here is the colorized magnetogram for that same period of time. That is yesterday plus today, June 30th and July 1st so far. If you haven't checked out our links, one of our affiliate/sponsors is Hemp Lucid, so check that out. The most popular products there are the CBD tinctures. So the water-soluble ones are a little bit faster absorbing and shorter acting. The oil ones are a little bit longer absorbing and longer acting. Make sure you consume some fat if you're using the oil suspension CBDs. That will help them absorb better and become more bioavailable. So check those out. You can find a link below this very video. You can also link to it on our homepage at smashomash.com. The Hemp Lucid CBD tinctures, very well liked around the world of CBD users. Help to reduce your inflammation and perhaps receive health benefits from those. Most popular products there are the water-soluble CBD tincture. So jump on the bandwagon and pick up some product from hemplucid.com. Today's featured product on the Amazon shop is the Tao of Jeet Kune Do. If you've never read Bruce Lee's opinions, and it's Bruce Lee's own fighting art, right? So Bruce Lee's fighting art is based on Wing Chun Kung Fu. But however, his own fighting art is completely different. It's designed as a functional fighting art, the Tao of Jeet Kune Do expanded edition. Check that out. You can find a link to that conveniently on our Amazon shop, amazon.com/shop/smashomash. Make sure you follow us on Instagram if you want to see all kinds of fitness and lifestyle posts. And make sure you check out our merch if you haven't. When are you going to join the Croissant Earth Society and realize that NASA's been lying to you? Don't you know that NASA's been lying to you, folks? I mean, so many agencies lying to so many people about so many things, trying to convince you that Earth is shaped like an oblate spheroid. I mean, what the heck? Didn't you ever hear of Operation Paperclip, folks? Obviously, NASA was founded by Nazis who are interested in convincing you that the Earth is shaped like a sphere. Like, what are you, crazy? You believe all this CGI nonsense that there's all these planets and stars and stuff out there, and the Earth goes around the sun, and all these crazy ideas. Wow, what about? I don't feel any movement. Obviously, Earth is shaped like the French breakfast pastry, not an oblate spheroid. So why don't you join the Croissant Earth Society and help people stop believing NASA's lies? Let's get to what's going on Croissant Earth, since we've got a reduction of the alert level at the Halema Uma'u lava lake. Yeah, Kilauea's alert level's been dropped down to yellow. It looks like the eruption has ceased there. There's a great image of the moonscape. That is the Halema Uma'u lava lake. Let's see what else is erupting. Taal at the Philippines producing a steam plume. Steam and ash plume likely there. Sulfur dioxide also. 7,480 tons released yesterday. Also 13 earthquakes and 5 2-minute-long volcanic tremor events. Karangatang continues to explode and produce an 8,000-foot ash plume. Mount Ibu producing unknown volcanic ash plume. Hey, I'm back. Tocono producing a 7,000-foot ash plume as it explodes. Again, Kilauea has had its alert level lowered to yellow. Popocatépetl exploding in central Mexico. Flight level 210, 21,000-foot ash plume, 15,000-foot ash plume over Guatemala from Fuego. Sabancaya exploding, flight level 240 in Peru, 24,000-foot ash plume. And Ubinas, also in the same country there, producing an explosive eruption, a 21,000-foot ash plume. Please don't pole vault the caldera. Next, seismic activity. And it's been a little more active than it was yesterday. Yesterday, very low levels were reported. And here are the past 24 hours. We'll cite quakes of a 5 magnitude and higher. So the first one on the list is this 5.8, 85 kilometers south-southwest of Bang Bang Lipuro. Bang Bang Lipuro, Indonesia, had a 5.8 at 12:57 Universal Time yesterday on June 30th. Continuing up the list here, we do have some quakes in California. They are not of a 5 or larger magnitude. There's a 5.3 in Argentina. That was at 3:29 this morning. A 5.8 struck the Indian Ocean at 7:29 this morning. And less than 2 hours later, a 5.1 hit the Kuril Islands. And guess what, folks? That brings us back to space. All right, so what else is going on in space, you wonder? Well, so do I. Let's get to it. So we initially started out the video today with the 304 plus 171 angstroms. Here we've subtracted the 171. Now you're looking at just ionized helium. And that's 24 hours from SDO, the Solar Dynamics Observatory. Again, high likelihood of solar flares, especially in the southeast and northwestern quadrants. There's the 171 angstroms by itself, the house favorite wavelength. And let's get back to space weather stats. Next on the list is a 10.7 centimeter radio flux, which has actually dipped down to 159 solar flux units. And let me just note something here. There's an important trend to note that some people don't seem to understand. You can see there's a sort of a general trend upward here with the upward part of the top part of the peaks. Yeah, the peaks, that's what they're called. There's an upward trend there. You can also see an upward trend in the troughs. Not really surprising to people who understand solar sunspot cycles. That is a 1-year graph depicting the radio flux in the black line, the 30-day sunspot average in the pink line, and the red line is a sunspot number, which you can expect to jump all the way back up to like 150 very soon. Probably today, I guess. As, again, there are 5 new named sunspot groups. 5 new sunspot groups that will get names today if they haven't already been named, and we'll cover that in a moment. Space Weather Enthusiast dashboard here forecasting a little bit of geomagnetic unrest late in the day today as we are expecting a minor glancing blow type coronal mass ejection impact. That's NOAA's forecast from the Space Weather Enthusiast dashboard. And let's take a look at Earth's magnetic moment from space for the past 4 hours. We have had some recent variations in the solar wind, and there is some erroneous looking data in there. We'll get to it momentarily. At the moment, however, things are geomagnetically calm. So there's that variation I talked about. Here is Earth's magnetic moment from the ground for the past 4 hours. And when we do have geomagnetic storm conditions, this would be a great piece of data to attempt to find whether or not the aurora is visible in your location. Is it worth going out to try to film it? Well, the Geospace Delta B will tell you. It's our ground magnetic perturbations map for the past 4 hours. And a quick note, if you want to see more real-time data about what's going on with the magnetic fields, the Boulder magnetometer is a good choice. So check that out. You can also look at the power induction, which would be this one down here. Where is that? It is the, I think they may have moved the links. Geoelectric field models, US and Canada, will also show you induction. So there's the Boulder magnetometers, and you can see there is an uptick going on there in the past couple of hours. Next, the planetary K-index is only at 1. It is geomagnetically calm conditions, like I said, and we may be seeing it rise now. Let's look at the real-time solar wind to see what's going on. So just a minor variation happening here. These really flat signals here look very erroneous. But current conditions reported are a very diffuse solar wind here at less than 3 protons per cubic centimeter. Solar wind speed, solar wind density 2.82 protons per cubic centimeter. Solar wind speed 477 kilometers a second. The rest of that unremarkable. Again, we are sort of awaiting a glancing blow CME impact, so we may see a mild geomagnetic storm. I wouldn't expect it to get above a KP6. I would expect it to stay below that. Let's take a look at the GOES magnetometers. Keep in mind these are in space, unlike the Boulder magnetometer, which is on the ground. And we do see some higher highs and higher lows than yesterday, and also some maneuvering by the GOES 16 and 18. That's those arc jet moments. They're using their thrusters and so on. Next, we're going to look at the heliospheric current sheet, and it shows some important data once again. So check this out. So there's a heliospheric current sheet. Earth is kind of right in the middle of a North Pole oriented current sheet. And we are still watching the North Heliographic Pole. If you look at that green blob kind of right here, sort of in the middle of that solar disk image, it snapped away from the pole and then it snapped back. Another successful forecast. Well, I actually said it's possible that it could snap back. We are still waiting for that to migrate. It's part of the solar cycle. Let's move to the line of sight field plot next. That's depicting the solar plasma in its north and south polarity. The solar plasma is oriented to one pole or the other, green for north, red for south. Here is the line of sight field plot. The B field depicted in blue, that's the field that goes through the magnet. It's sort of like a net of the two solar fields. And then you can see the photospheric fields in grayscale. Earth right in the middle of a North Pole current sheet, and we've got plenty of North Pole-oriented coronal holes on the Earth-facing portion of the solar disk. So there's a lot of plasma headed in our general direction at the moment. There are the past 4 days in our line of sight coronal hole plot. Again, the coronal holes we've currently got are North Pole oriented. So let's take a look at those from our favorite wavelength for that, the SDO 211 angstroms wavelength. So those are all North Pole oriented coronal holes. And we can expect maybe a slight and short-lived enhancement from this coronal hole down here in about 3 days. Next, we'll move to sunspots. So there is the sunspot situation. And again, we are waiting to see the naming of at least 3 or 4 more new groups over here in the east. So this one got a name, 3356. We're also waiting for 3357, 3358, and 3359, possibly even 3360. Let's take a look at sunspots from SDO intensity gram. So there you go. There are the past 24 hours. This group here is growing rapidly. And again, a high likelihood of large solar flares both in the southeast, which is down here, and the northwest. And if you're wondering why it's called the east and west, is because over here is where, well, that is where the sun rises. Hence, that's the east. That's where sunspots rise. Over here is where sunspots set. Hence, that's the west. Anyway, next we'll move to energetic particles and solar flares. And it's been, well, there's some interesting news here also, because while there have been no solar energetic particle events in quite an extended period of time, the X-ray flux has now come up to a much higher background level. Some of the highest levels we've seen during the solar cycle here, I mean, we did have a point where we were almost at an M-class background X-ray flux. At the moment, we are now well into the C-class X-ray flux at about a C, just under a C1.2 for the background X-ray flux. Flaring has been light. Don't expect that to continue because, well, there is a lot of action. So here are the past 24 hours from the SDO in 131 angstroms. That's another species of ionized iron. We've also got 94 angstroms. Today featuring a lot of non-composite imagery and composite imagery, as we bring you the most detailed solar imagery and space weather analysis you'll find in the known universe. Moving right along, we want to know what's going on overhead. So let's take a look at a star chart, because we like to provide a holistic concept of what's going on in space. This is what's going on overhead Lehigh Valley, Pennsylvania. You got Jupiter and Saturn up there, and also Mercury very close to the sun. And once again, if you're viewing the dusk sky just after sunset, take a look at Mars and Venus, super close together. And let's do a solar system forecast. Here's where stuff is today. Let's advance this 1 week. Mercury swinging around for another run here to blow past Mars, catch up with Venus and Earth. That's where things will be on July 9th. That's your 1 week solar system forecast. And let's take a look at some coronagraphs. There's a great view of Mercury and some rather minor coronal mass ejections. I mean, that one out of the north is pretty major, but it's not earthly directed. That's yesterday's coronagraphs. And here are today's. Only 42 frames there. Let's take a look at some more imagery from Soho Lasco C2 and C3. No new earthly directed CMEs detected there. We'll also show stereo A for the sake of completeness. I should have this scrolled over. There we go. That's a little better. Sweet. So there is stereo A located on the left. This coronagraph here. Soho Lasco C3 on the right. And nothing doing yet, but we've certainly got the stage set for some major earthbound activity. So fingers crossed for that. And if you're frightened, I don't know what to tell you. It's really not very scary. We're just hoping to see the aurora. And let's talk filaments. So filaments are a big deal because they can turn into coronal mass ejections. Sometimes they collapse. Sometimes they reorient themselves and get anchored to a different spot on the sun. And sometimes they blast out into the solar system. When they strike Earth's magnetosphere, they do all kinds of different things. Produce the aurora, pipeline, railway, and power grid induction. They can even cause health effects if they strike the Earth hard enough, believe it or not. It's fairly well documented. However, most likely if you're getting a headache, it is probably not from space weather. Something like 80% of headaches are still caused by dehydration. Anyway, you can see some huge filaments here, and this one down here needs a name. So I would say name that filament. And if you want to name filaments, you got to join us on Twitter. So let's demonstrate this. Again, if you want to name that filament, that's where you got to do it, on Twitter. And why do I have no post button? Am I not logged in? Anyway, if you want to name filaments on Twitter, make sure you join us over there. Follow the hashtag #NameThatFilament, and we'll name filaments. They get named after living people. And here are some views of, oh, we forgot to cover coronal mass ejections. Who knew? Who knew, folks? So there are CMEs. Again, they're pretty minor the past 24 hours. There's the past 24 hours zoomed in a little closer. They're zoomed in a little bit closer. Here's just 193 angstroms by itself. And here we've added 304 angstroms to show the great contrast of those filaments. You can see some quite well-defined ones. And again, this one down here is the one that ought to get a name. So follow the hashtag #NameThatFilament over on Twitter to name that filament after a living person. Alrighty. Sometimes I actually tweet during the video just to show folks how to do it. I know it's very complicated. Here are the past about 2.5 hours from the GOES 18 SUVI. Looking at ionized helium, and we did have a little bit of flaring activity from this northeastern sunspot group. So again, major solar flares possible up here, and down here especially. This is a beta gamma class sunspot group at least as well, so there is a possibility for large flares from there, but mainly the southeast and northwestern limbs. Let's go to bonus features next. So there is our satellites community dashboard. No charging hazards here at the moment. Smooth sailing for satellites is the current situation. GOES electron flux here just moving into warning levels once again, and you can expect a huge dip in this if we do indeed see a CME impact. It's just a standard feature. The data gets erroneous when you see the CME impacts and coronal hole high-speed streams. Here's the one-year graph to put it in context from Solon.info. Yeah, Solon.info. Good stuff. Lots of data there. It's the same site that we use for the sunspot number and 10.7 centimeter radial flux one-year graph. That's a one-year graph for the relativistic electrons. Here's the forecast model. And again, we are expecting this to dip way down if we do indeed see a coronal mass ejection impact. Next, we'll show the layer of the atmosphere where it's measured, the F layer. And here it is, the vibrational frequency in megahertz. Millions of vibrations per second. We show it daily on the channel because you never know if the data will become useful in the future. So part of the purpose of these daily space weather videos is to archive certain aspects of space weather because they could relate to other things. They may have unknown predictive value, as there are some signals that could be generated from the Earth side showing up in the space weather data and vice versa. So that's what's going on in the ionosphere, the bridge between Earth and space. And if it looks confusing to you? It looked confusing to me too when I first looked at it. Here is the anomalygram. That is anomaly in megahertz from the 30-day median. So plenty of low-frequency anomalies here happening. You can expect those to increase a lot if there is a CME impact today. I think I rated the possibility of like 30% of a CME impact. I thought it was probably more likely to miss to the east, but hey. It can be tough to tell, especially when stereo A and stereo B, well, when stereo A especially is so close to the Earth. Anyway, here's the latest image. That's 1245 universal time ionogram and 1245 universal time anomalygram. Total electron content is free electrons out to about 12,500 miles of altitude where your GPS satellite is located. There is the coupled thermosphere, ionosphere, plasmasphere, electrodynamics model. A little bit of anomalies happening there in the southern hemisphere for the most part. Those are the most likely places to see errors in your GPS. Turn on Wi-Fi location accuracy. If you're expecting those, it'll help you navigate. Here's a 10-day anomaly from the North American electron content average. Again, this is about 12,500 miles of a run there. I'm actually seeing kind of low electron contents over the Caribbean, North America. A lot of blue on the map there. Those are low electron counts. It's literally a count of the electrons. And we'll close out the space weather section of the video with the latest SDO graphics. So there is the continuum, and there is the magnetogram. This sunspot, it does have deltas. It is beta gamma delta class, the most likely sunspot class to produce a large solar flare. For example, this little red area right here, that is a delta. A strong south pole magnetic field there, very close to a strong north pole oriented umbra. So that is becoming increasingly likely to produce an X-class solar flare. Also, this group down here is promising. There is certainly quite a bit of plasma, and of course this group here growing kind of rapidly as well. So lots of stuff going on. Again, we'll have at least 3 more named sunspot groups today. And let's move to meteorology. So we're starting things out with some wave chasing today. Yeah, some wave chasing. Because I'm a wave chaser. And I've been known to stay in the ocean for hours and hours and hours when there are sweet waves coming in. Currently, the biggest ones are in a very unfortunately unpopulated portion of the planet, deep in the South Pacific, near the Southern Ocean there. Probably nobody there to enjoy those 31-foot waves. Seas are pretty calm here. Besides around the Southern Ocean area, these receive honorable mention as well. For the most part, the rest of the planet pretty calm. It's pretty smooth sailing for both satellites and for humans. Anyway, let's move to our regularly scheduled meteorology stuff. That is the surface wind scenario for the eastern portion of the planet. That is the jet stream scenario. And we're going to actually show jet stream forecast for the entire northern hemisphere on today's content. We got a backward jet stream over the northern Indian Ocean. Here are the jet streams of the Americas, the Western world. And we've got fairly coherent jet streams over the U.S. and a fairly odd jet stream there over the Gulf of Mexico. You can see the jet stream there blowing southwest, actually. Here are the surface winds of this side of the planet. Strong low there loitering off the coast of Mexico. Surface winds of the central world. There you have them. And these are the jets. The 250 hectopascal winds are what we're looking at. And let's move on to take a look at pressure at the surface. So this is the mean sea level pressure. Strong low here approaching Alaska, it looks like. Southern Ocean contains a series of strong lows. And it looks like clear skies over the Azores, as we've got an anticyclone dominating the North Atlantic. Here's the clouds and fog scenario for the western world. A bunch of low clouds there off the coast of South America on the west coast. Low clouds there, big time. That's clouds and fog. 3.9 micrometer infrared radiation from the NASA GOES Interactive Weather Satellite Suite. Croissant Earth, depicted on a fake CGI NASA oblate spheroid template. Next, our smoke map. And yeah, it's a story. It's definitely going to be in the news. So yeah, there's your smoke forecast, and it's pretty smoky. Pretty smoky indeed. Now there is precipitation moving into the mid-Atlantic states, and we'll show you forecasts here in a minute. First, we'll show the weather.gov map, the official homepage of the National Weather Service. Weather.gov, those are heat warnings there in the Gulf states. We'll briefly show you the key. Weather.gov is where to go to get your weather alerts. And here come some forecasts. First of all, check it out, the temperature anomaly forecast for the entire northern hemisphere. So that's temperature anomaly in degrees Celsius based on the GFS 72-hour model. And one of our viewers, shout out to Wote Arty Noobs, talked about the jet stream. There's the jet stream forecast for the entire northern hemisphere. Once again, that is 72-hour GFS 250 millibar wind speed model. Jet stream's going to get incoherent over the U.S. again. We're going to have weird weather patterns, and people who do not understand atmospheric physics, meteorology, and aircraft will claim that mankind controls the weather. It's pretty sad. Here is the U.S. jet stream forecast. Again, you can see the jet stream becoming incoherent there in the next couple of days. That will cause weather systems to perhaps move in odd directions and so forth, convincing people of things that are not reality. Last but not least, pressure and precipitation for the lower 48. And here's your lightning mapper. Heavy lightning there over Illinois and Indiana and Ohio, Kentucky, etc. Well, you see the graphics, right? No need to explain. That is what is going on, and here is the real-time lightning map. We'll only show it briefly since this video was not streamed live. We've got some active cells here moving towards Cincinnati, I suspect. Next time you hear thunder, check out lightningmaps.org. It could save your bacon, just like smashomash.com could save all of our bacon. Who knows? Well, if you haven't seen our own website, smashomash.com, go check it out. It's got our links there. You can get extra content, especially if you join the Smash team. So smashomash.com is the official homepage of the Smash News Network, least busted name in news. Launched all the way back in February of 2019. So we saw the writing on the wall and realized that we needed our own site. So there it is, smashomash.com. Go check it out. Support the channel with clicks if you're unwilling or unable to open your cobweb-encrusted wallet. And send us a few bucks per month to produce the content by becoming a member of the Smash team. Or you can even become a patron still. pick up some product from Hemp Lucid or from the Amazon shop. You can also find a permanent invite link to our Discord chat there. Smashomash.com/SmashTeam is the official subscription services site of the Smash News Network, least busted name in news. And congratulations on realizing it exists. Frankly, we're surprised because of the pathetic, putrid, and disgusting state of censorship on the entire internet. Accountability always comes, folks. Accountability always comes. And if you think you can silence people forever, accountability will come for you too. We'll close out the video with U.S. Doppler radar and focus on the lower 48. We'll also show clouds and fog and the water vapor map. And another interesting thing going on here, you can see these systems are starting to kind of make a turn to the southeast, where they're going to run into this high pressure blocking feature. That's going to cause some big pressure gradients. Also, you've got a little bit of an impulse of dry massive air right here, pushing that moisture up to the northeast. You can see this is actually creating a little bit of a barrier here. That's another high pressure zone. High pressure zone over the Gulf of Mexico as well. Anyway, here's your recap. U.S. Doppler radar, that shows vertical motion in the air column from ground-based Doppler systems. It doesn't show chemtrails. It doesn't show HARP, and it doesn't show geoengineering. It shows vertical motion of things like water droplets and ice crystals. Here is clouds and fog from the 3.9 micrometer infrared radiation spectra. We use that to see clouds and fog at nighttime when it's too dark for the visible satellite. And there is the water vapor map, which will clear things up if your Doppler radar is unclear. Anyway, we hope we were clear by citing a bunch of facts on the channel. Now, since facts are very scary and very controversial, I'm going to have to get back to the bunker because I am spooked of all that spooky, spooky stuff in space. Pardon my sarcasm. We'll see you soon, and in the meantime, may that solar wind be at your back. Look out below. Whoa!